Okay, so here we've got a question on Leibniz's theorem. We've been asked to find the fifth derivative of this equation in this form, and then we need to state the values of a, b, and c. So this is essentially the binomial expansion when we use the product rule to differentiate this. So if u is equal to x cubed and v is equal to sine kx, we need to create a table to show the first 5 derivatives of each of these functions of x. So to work out u prime and v prime, we can differentiate x cubed to get 3x squared, and we can differentiate sine kx to get k cos kx. And then for the second derivative, we get 6x and negative k squared sine kx. If we differentiate these again, we get 6 and negative k cubed cos kx. And then when we differentiate the 6, we get 0 and 0 again. When we differentiate negative k cubed cos kx, we get k to the 4 sine kx. And then finally, when we differentiate this, we get k to the 5 cos kx. Okay, so now we've got our derivatives, we can substitute these into our formula. So this will give us the fifth derivative of y will be 5 times 0 of this one and this one, then 5 times 1 of this one and this one, 5 times 2 of these two, and then 5 times 3 of each of these. When we've got 5 times 4, the product will be 0, and the same for 5 times 5. So now we can simplify all of this by working out each of these and multiplying it by the coefficients of the x term. So at this point, we can begin to factorize out the terms. I'm going to begin by factorizing the cos kx terms, so this one and this one together, and factorizing the sine kx terms, so these two. And now from our cos term, we can factor out the k to the 3 and the x term. Then for the sine term, we can factor out the 15 and the k squared. So now you can see each of these are fully factorized. And if we go back to our question, we want to work out the value of a, b, and c. So a is equal to negative 60, b is 15, and c is negative 4. Okay? Well, thank you for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the lessons on this topic from my website, mrmathematics.com.